Okay, so in lecture 4, we're going to talk about linear inequalities and interval notation. So a linear inequality is in one variable is an inequality that can be put into one of the following forms. So it's just like a linear equation, it's just that we're going to introduce inequalities. So ax plus b is less than c, ax plus b is less than or equal to c, ax plus b is greater than c, or ax plus b is greater than or equal to c. Same form as linear equations, just inequalities. So here's an example that we could try to solve. So instead of getting a single solution, we're going to get a set of solutions. So we're going to try to solve these, and we'll use the same techniques that we used for solving linear equations. So we'll add one. We'll try to bring the x terms to the same side and the constants to the same side. So we'll bring this 1 over here, and let's bring the 2x to the other side. So we'll subtract 2x from both sides. And what will we be left with? We'll have an x, but then the 1's go away, and the negative 2x and the 2x cancel, and then we're left with 2 over here. So x is strictly less than 2. Okay, so that's our solution set. Now we could represent the solution in a couple of different ways. So one way is you could represent it like this, okay? But another way that we can represent this is using sort of a real number line and a graph. So if we have a real number line, what we could do is denote this inequality on the real number line. So how would we do that? Well, we could label 2. And because we're not going to include 2 in the solution, we're going to use an open circle. And we're going to fill in this region over here. So everything that's in the blue is an x value that satisfies this inequality. So for example, the value 0 is over here. Right, so the value 0 is strictly less than 2. So we'll use open circles for to denote that we're not including it. And another way that we can represent this is using interval notation. So the way that that works is we would have 2 in open parentheses here, and we're going to let x be anything less than that, so we're going to go all the way to negative infinity, and we'll put another parenthesis there. So open parentheses like this designate that you're not including those values, and let's look at what the other possibilities would look like in other situations. So interval notation in general, we're going to follow this convention here. So here is the inequality notation. So x is less than 2. The interval notation for that would be negative infinity to 2, and the open parentheses here mean that we're not including those values. Okay, so since there's no equality here. And then the graph, we could do this 2 ways actually. We could graph it using parentheses and brackets. So we're kind of following from the interval notation here. So if we write 2, then using parentheses, I could put my open parenthesis here, and then we can kind of fill in this part of the graph. Okay. Graph using open circles and closed circles, like I did above, we would designate 2, and we're going to put an open circle because this is strictly less than, and then just fill in the part of the real line that has the solution. Okay, if we were in a situation where it was less than or equal to 2, the interval notation changes to a bracket like this, a closed bracket. And we would denote that on the graph by just putting a bracket like that and filling in the same region, because now we're including 2. And in the circle, the open or closed circle When we're including 2, that's when we'll fill in the circle. So open means you're not including that in the region of interest. Closed means it is included. All right, so it would look like this. Well, what if x is greater than or equal to -3? Well, we can write down -3 and greater than or equal to, so we're going to have a bracket, right? So -3, and since we're considering x values larger than this, we're going to go from -3 to positive infinity. So we'll put a bracket here, and then we'll fill in this region, right? So these are, every value that's up here is something larger than -3. So for example, 0 would be included here. And in open or closed circles, well, it's we're in greater than or equal to. So the equal to means that we're going to have filled in circle, -3, all the way to positive infinity, and what if x is just greater than? Well, it'll be a lot like this situation up here. So since it's not greater than or equal to, we're going to have an open parenthesis and then -3 to infinity. And that will look like this. Right, so using parentheses or brackets, right? So open parenthesis there, and we'll have an open circle from -3 to infinity. Okay, so let's continue solving our linear inequalities, and we're going to graph the solution set for this linear inequality. Now, one thing I want to point out that hopefully you, after reading your textbook carefully in this section, you'll have noticed that we need to reverse inequalities when we multiply or divide by a negative. All right, so when we're trying to solve this particular linear inequality, we're going to have to divide by this -7 to isolate the x. So let's do that. So we have -7x greater than or equal to 35. So we're going to have to divide by this -7. And because we're dividing by a negative, we're going to reverse this inequality here. So it's now going to be a less than or equal to. So by doing this, we will get an x on this side, and over here we will have -5. So we're asked to graph the solution, but let's do this in a couple of different ways. So one is, well, it's going to be less than or equal to, so we know that it's going to be a filled in circle like we had above. So let's do a filled in circle, denote -5 here. And we're going to consider x values that are less than or equal to this. So that's going to be on this side, right? Less than or equal to. So it might be a good idea to either switch colors or just make this very clear that you're talking about this side when you're doing the graph portion, when you're solving your homework problems and whatnot. Okay, and let's also write out the interval notation. So since this is including -5, that would be a bracket, and we'll put -5 here, and we're going to -infinity. So sometimes it's actually easier to write out the interval notation after you've graphed it like this. It's a little bit easier to actually see that interval visually. Okay, so how about this one? Well, what did we do before when we encountered a fraction like this? We usually multiplied by the lowest common denominator. In this case, there's only one fraction, so let's multiply both sides by 3. And by doing so, we're going to get rid of this 3, and the numerator will become negative 6x. And 3 times negative 8 will be negative 24. And then here we're going to have to divide by a negative, all right? So let's divide by negative 6. And this side will become x, but we're dividing by a negative, so this will become x is greater than, and what does this simplify to? Well, 4. Okay, so graphing this, we're going to have 4. It's going to be greater than, so we'll put an open circle there. So x is greater than 4. So when you're graphing these things, what you can do to convince yourself that you have the right, you're filling in the right portion, is you can kind of pick a sample value inside there and just double check, does that make sense? So something that would be over here would be like 5, for example, and 5 is certainly greater than 4. And you could also check if it satisfies the original one as well. Okay, and this simplifies to what interval notation? Well, it's open, so we're going to use an open parenthesis, and it goes to infinity. So these are the same representations for this inequality here. So how about this linear inequality? So here we are going to try to isolate the x, and we will divide by 4, but that's not a negative, so we're not going to have to change this inequality. So divide by 4, we're left with negative 5 is greater than or equal to x here. Okay, so that's our solution, but we're asked to graph the solution set. So let's just do that real quick. So negative 5 is greater than or equal to x, or another way to say that is x is less than or equal to negative 5. So we're going to have negative 5 here, right? So I'm giving you this example because I want you to be very careful. You know, don't immediately just start drawing without actually thinking about what it says up here. So the x values are less than or equal to negative 5, and that's what you want to draw. You want to draw the x values that satisfy this. So those are going to be over here. Right? For example, negative 6 is over here, and negative 6 is certainly less than or equal to negative 5. Okay, and another way to write this in interval notation, well, again, once you have the graph, it's a little bit easier, but we'll have negative 5. We're going to use closed brackets here to negative infinity, and that's going to be an open bracket. Okay, so for this one, first, let's bring the 5 over, and we'll sort of isolate the term that has an x in it. So add 5 to both sides of the inequality. So we'll have negative 2x less than or equal to 20. Okay, so remember, you're only going to have to change that inequality when we're talking about multiplication or division by a negative. You can add and subtract. That's not going to affect that. All right, just be aware of that. But here, we are going to have to divide by a negative 2. Okay, and this is a good example of something you don't want to try to do too many steps at once. So make sure that you do that addition. You get the two sides isolated where you have the terms with x on one side, and then try to isolate the x. Okay, don't try to do too many terms at once, because then you might make the mistake of changing inequalities when you're not supposed to, and it can become a mess. Okay, so we're dividing by negative 2 here. That's going to swap this, and we'll have an x, and this will be negative 10. So there we are. So let's graph that. So negative 10, we're going to be x is greater than or equal to negative 10. So let's fill in negative 10. And x is going to be the values that are greater than or equal to this. So we're going to fill in this side. Okay, and in interval notation, what are we going to have? Well, it's greater than or equal to, so we're going to have a bracket, -10, all the way up to positive infinity, right? But not inclusive, because that's not a number, right? And so here's our solution. Of course, it only asks you to graph the solution, but it's good to get used to doing all three. Okay. Well, what about this one here? Okay, so this one is a little bit more involved, but we have a few fractions, and one trick that we used before, you don't have to do this as the first step, but it might help you, and that is to get rid of the fractions. And how did we do that? Well, we multiplied by sort of a common denominator. So if you find the least common denominator, in this case, it would be 12, right? So if I multiply both sides by 12, what happens? Okay, so we get 60 minus, so 12 times a third, that's 12 divided by 3, so that's 4x is greater than, and 12 times a fourth, that's 12 divided by 4, which is 3x, and 12 times 2 is 24. Right? So again, you don't have to do this multiplication here, but if you do, it'll get rid of the fractions immediately. If you choose to do it later, it's fine. You'll still get the same answer in the end. It's personal preference. So at this point, what could we do? Well, we can bring the x terms to one side and the constant terms to the other. So let's subtract 24 from both sides. And we can add the 4x to both sides. You could do this in 2 steps or 1 step. So 60 minus this is 36. And this term is gone. And then we're only doing addition and subtraction, so there's no need to change this. And this will be 7x. And now the 24 is gone. And so at this point, we're going to isolate the x. We're going to divide both sides by 7. And that's our answer, right? So 36 divided by 7 is greater than, strictly greater than, x. Okay, so how do we graph that? Well, using the interval notation, we're talking about x being less than 36 over 7. So that's going to be an open circle. And again, remember, there's 2 ways that you can read this, right? 36 over 7 is greater than x, or x is less than 36 over 7. But just be careful. We're going to be talking about what's over here. Oh, I should label this 36 over 7. And x is going to be less than this. Okay? So for example, the value 0 is over here, isn't it? Because this is a positive, so 0 is over here. And 0 certainly is less than 36 over 7. So, you can kind of pick some test value that can help you make sure that you're shading in the right region. And this will be an open parenthesis, 36 over 7. And we're going to go all the way to negative infinity. Okay? And there we go. Okay, well, how about this one? So here, again, we're starting out with some fractions. So an option is we could, move these constant terms around, but maybe we could just get rid of the fractions immediately. So we can multiply by the lowest common denominator, which would be 6, right? So if I multiply by 6, what happens? Okay, so we'll get negative 12, but then 6x over 3. So 6 divided by 3 will be left with 2x. And 6 divided by 2 is 3, so we'll have 3x. And 6 times minus 5 will have minus 30. So we can bring the 12 over to this side. and we could subtract the 3x to the other side just to isolate. What are we left with? So the 12s go away, but we have a negative x here, right? Is greater than the 3x's go away, but then you're left with what? So negative 18, is that right? Yeah. Okay, so then x. So here, what could we do to get rid of these negatives? Well, we could multiply both sides by -1, right? So if I multiply both sides by -1, in other words, I'm just going to negate both sides, right? So writing this is the same as multiply by 1, right? So what's that going to do? Well, this is going to become an x, but I'm negating this, so this is going to swap the inequality because you're multiplying by a negative, and then this will become 18. So there's our solution. And we can graph that real quick. Right? So we have 18. And we're considering values of x that are less than 18, so that's going to be over here. Okay. And in interval notation, if we want to do that, we'll have 18 open bracket to negative infinity. Okay, so how about this one? Well, there's actually a couple ways that you could proceed. One way is you could try to immediately get rid of these fractions. We can multiply by the lowest common denominator. So that would be 8, right? So 8, I can multiply both sides by 8. Alternatively, you could distribute and then multiply by a lowest common denominator. So try it both ways and see what you think, which way maybe is faster. So let's distribute first, since that's sort of the common thing that we did first anyway. So we'll distribute this in. So -1/2 times this, we will have negative x, and then we'll have, so -1/2 goes in here, -1/2 goes in there, we'll have -1/2. And over here, if I distribute the -3/8 into these two, then we'll have -3/8 x and minus 6/8. So again, see, we're still going to have to multiply by lowest common denominator. It doesn't really matter where you do that. So we're going to multiply both sides by 8, and we'll have -8x, and 8 times this will have -4, because that'll be 8/2. We're multiplying by a +8, so we don't have to switch this. But then 8/8 is, those are going to reduce, so we're left with -3x. 8/8 is reduced, so we're left with -6. Okay, so at this point, we can try to isolate the x. So we'll have to bring the terms with x's to the same side. So we could, I mean, it's up to you. Maybe we'll bring the x's to this side. So we'll add 8x to both sides, and then we'll bring the 6 over here. So we'll add 6 to both sides. So that'll get rid of the 8x. We're left with 2 less than or equal to, adding 8x will give us 5x. And dividing both sides by 5, since that's positive, it's not going to mess with this inequality. We're not going to have to change that. So we'll have 2/5 less than or equal to x. In other words, x is greater than or equal to 2/5. And could we write this out in interval notation? Well, let's graph it as well. So graphing it is sometimes a little bit easier. So greater than or equal to, that's going to be a solid circle because we're allowing it to be equal. So we'll label that as 2/5, and so x is going to be greater than or equal to this. So we have to pick values that are larger than 2/5. Okay, now again, if you want, you could start this problem by doing this multiplication. So that's sort of our solution 1. And solution 2, we should get the same thing if we were to initially multiply by the lowest common denominator. So instead of distributing first, we could do that. So if I multiply both sides by 8, well, what's going to happen? Well, I'm going to get a reduction here to -4. And the 8's reduced, and I have a -3. And then distributing this, and you have -8x minus 4. So distributing, now we have to distribute this -4. So see, either way, you're going to have to do some distributing. And we'll have a -6. And now do you see at this point, it's actually the same as what we have right there. It's just we did that in sort of a different order. Again, it doesn't matter. You'll get to the same solution in the end. It's sort of personal preference. So whatever you prefer, as long as it's correct.